Okay, and now let's talk about the general procedure of the sketching graphs. Okay, functions. Example, if y equals to x cubed minus 3x squared plus 4, it equals to x plus times x minus 2 square, also, and the step 0, and to find the endpoints, and also to find the intersection y and the x-axis points, and at x equals to -1 and x equals to +2, we know that y equals to 0. This is the first intersection point, intersection axis point, I'm sorry, and the second one at x equals to 0, we know that y equals +4, and after that limit x equals to infinity, and it will be plus infinity, and these are the endpoints, and the limit x equals to minus infinity, so our function will goes to minus infinity. So now step 0 has been completed, and now step 1, we have been gathering some informations about the graphic, about the function, and after that, when we complete all of the data, we can easily sketch the graph of function, and now step 1, and the step 1, please find the factors of y prime, and the y prime equals to 3x squared minus 6x, and it's equals 3x time, x minus 2, right? And that means, x equals to 0 and x equals to 2. These are factors of the y prime, and on the x-axis, what can we say? This is minus infinity, and this is 0, and this part is +2, this is plus infinity, and we know that if x is less than 0, so this part will be plus, and after that, if x is larger than 0 and less than 2, this part sign will be minus, and this part will be plus again, and so that we can say here, increasing, and for this part decreasing, and for this part again increasing part of the function. So as you see, for this point, increasing to the decreasing, so this will be local maximum, and as you see, decreasing to the increasing, this point will be local minimum point. Okay, and they continue with the step 2. Step 2 says as twice derivation of y, and it was the y2 prime equals to 6x minus 6. It equals to 0, and the x equals 1. And what can we say about it? And again, okay, this point is 1, okay, and here is minus minus minus. Okay, when you take the any value which is less than 1, okay, and the y2 prime will be negative, okay, and when you take any value which is larger than 1, okay, and the y2 prime will be positive, okay. So for this interval, okay, concave down because of minus, concave down, and here is concave up, okay, and for this point is inflection point. Okay, and the step 3, combine all values in one table. That means we have just collected lots of information about the graphic, and now we can combine all of the information in one table. Okay, we can easily see the characteristic of the function. Okay, and combine all in one table. Okay, and okay. And firstly these points, this is x points, okay, and the minus infinity, and here is minus 1 and 0, plus 1, plus 2, and plus 3, okay, and this is the plus infinity. Okay, and this part is y, and this part is y prime part, and this part is y2 prime, okay, and which was the factor of y2 prime? It was x equals to 1, okay, and that means that here is a factor, okay, for the y2 prime, and the 0 and plus 2 was the factor of y2 prime, y prime, I'm sorry, and after that the minus 1, okay, minus 1, and the plus 2, okay, yes, and the plus 2, okay, and these are the factors of the y function. And after that, please look at the y2 prime, okay, and I'll use the green pen. We know that here it is minus 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 and plus 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 plus, okay, and after that we know that for the y prime, okay, and the plus 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 minus minus plus plus plus, you must look the higher degree of the polynomial function sign, okay, and if it is plus, so you must start from the infinity section and the plus plus. When you see the factor of the function, this is the y prime function, and you will change the sign and it will be minus, and you see again a factor of the y prime and you will change it again and it will be plus plus plus, like that. And after that, please look at the y function. We know that the highest degree of the polynomial function, which is the 3, okay, and this sign is plus, so we have to start the plus sign, and okay, and this will be, and the minus 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 plus plus, okay. And to understand the local maxima and the local minimum values, we must look for the y prime, okay, and as you see, okay, and the increasing, because of these are plus, okay, increasing, 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 and the decreasing, okay, and increasing, increasing, increasing. So 0 is the local maximum, okay, and for the plus 2 is local minimum. And now when you look for the another point about which is the y2 prime, as you see, negative negative, and it will be concave down, okay, here, and the concave down, and after that this will be concave up, okay. As you see, this point is, okay, inflection point, concave down and concave up, okay. And when you try to sketch this function on the coordinate system, and you must look for this information, okay, and please look at the root of the function, okay. This will be minus 1 and plus 1, okay, and the minus 1 and I'm sorry, plus 2. This is 2 and minus 1, and after that, when x equals to 0, okay, y was 4, right, okay, and this is the 4 value, and at the plus 1 value there will be changed, okay, and when x equals to 1, okay, please put the values here, okay, and the f of 1, which is the inflection point, we know that, and the 2 times, okay, minus 1 square, and it will be plus 2, okay. So here will be inflection point, okay, and our functions will comes from minus infinity, because of the when x approaches to minus infinity, y is minus infinity, okay, and so what can we say? It will increase, okay, and when you approach to x equals to 0 point, okay, and after that it will be decreased, okay. So let me sketch it, okay, by the blue pen, okay, and now increase, that point is local maxima, and now I will our function's characteristic is concave down, okay, and the concave down again. When you, okay, see the inflection point, your concavity characteristic will be changed, and it will be concave up and decreasing again, okay, and you will go to the 2 point, okay. When you approach to 2, okay, your function will be increased again, okay. So this will goes like that, okay, and as you see, this point is inflection point, and this is the factor, and this point is local maximum and this point is local minimum. This is inflection point, and the whole the graphic is y equals to x cube minus 3x squared plus 4. Okay, and maybe we must learn some definitions about the asymptotes of the graphic. Okay, and let me continue with them. Definition: the graph of y equals f of x is a vertical asymptote at x equals to a if either limit x equals to a from left hand side, f of x equals to minus or plus infinity, or limit x equals to a from right hand side, f of x equals to minus or plus infinity, or both. Okay. Example, what I mean. Okay. Find the vertical asymptotes of f of x equals to 1 over x square minus 1. I'm sorry, x square minus maybe x. Okay. And we know that the denominator part of the function x square minus x, it equals to x times x minus 1. Okay, and these are the candidate vertical asymptotes, x equals to 0 and x equals to 1. These are the vertical asymptotes. Okay, and prove it, and when limit x equals to 0 from left hand side, okay, 1 over x square minus x, it's equal to plus infinity, and the limit x equals to 0 from right hand side, this time 1 over x square minus x, it's equal to minus infinity. As you see, x equals to 0 is vertical asymptote, and now another point, which is limit x equals to 1 from left hand side, 1 over x square minus x, it's equal to minus infinity, and also limit x equals to 1 from right hand side, 1 over x square minus x is equal to plus infinity, so that x equals to 0 and the x equals to 1 values are vertical asymptotes of the function. And another definition, okay, the graph of y f of x has a horizontal asymptote, asymptote y equals to L if either, okay, limit x equals to infinity, f of x equals L, or limit x equals to minus infinity, f of x equals, okay, L or both of them. Okay, and the example, find the horizontal asymptotes of f of x equals to 1 over x square minus x, and okay, g of x equals to 3x square minus 7 over 6x square plus 3. Okay, and the limit x equals to minus n plus infinity 1 over, okay, x square minus x, okay, and it's equal to 0. So 0, x equals to 0 is horizontal asymptote. I'm sorry, y equals to 0 is horizontal asymptote. Okay, and another function, limit x equals to, okay, minus or plus infinity, okay, and the 3x square minus 7 over 6x square plus 3, and it equals to limit x equals to minus or plus infinity, okay, and the 3 plus, okay, and the, I'm sorry, 3 minus 7 over x square over 6 plus 3 over x square, so it's equal to 3 over 6, which is equal to 1 over 2, okay, and the y equals to 1 over 2 is horizontal asymptote of the function. Okay, and the definition, the straight line y equals to ax plus b, a is not equal to 0, is an oblique asymptote of the graph of y equals to f of x if either limit x approaches to infinity, I'm sorry, minus or plus infinity, okay, and the f of x minus ax plus b equals 0. Example, f of x equals to x squared plus 1 over x, it's equal to x plus 1 over x, okay, and the limit x equals to minus or plus infinity, okay, and the f of x minus x is equal to limit x equals to minus or plus infinity, okay, and the x squared plus 1 over x minus x, limit x equals to minus or plus infinity, 1 over x is equal to 0. So y equals to x, okay, is oblique asymptote. And they continue with the example. If y equals to x times e to the minus x square over 2, okay, and sketch the graph, okay, and firstly, of course, we have to find lots of information, and the step 0, step 1, step 2, like that, and but I want to, okay, research about this horizontal and also some vertical asymptotes if it exists, okay, and the limit x approach to minus infinity, okay, x times e to the minus x square over 2, okay, is equal to, we know that the 0, okay, and again limit x approach to plus infinity, x times e to the minus x square over 2 is equal to 0, okay, and the y equals to 0, horizontal asymptote at both ends, okay, as you see, minus infinity and plus infinity, and the y equals to 0, it equals to x times e to the minus x square over 2, and so that we know that x equals to 0, okay, and this is the intersection point, but the y prime equals to, okay, 1 minus x square times e to the minus x square over 2, it equals to 0, okay, and the x 1 comma 2, it equals to minus and plus 1. These are the critical points and some local maximum and local minimum points of that. And we know that when x equals to plus infinity, okay, and the y will be e to the minus 1 over 2, and when x equals to minus 1, and the y will be minus e to the minus 1 over 2, okay, so these are the critical points, okay, and we know that this is minus 1, this is plus 1, okay, and this will be minus, 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 plus, plus, minus, 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 and the decreasing and the increasing parts, and also again increasing parts. So this is local minima, this is local maxima, and the y2 prime equals to x times x square minus 3 times e to the minus x square over 2, okay, and equals to 0. So x equals 0, x equals minus and plus square root of 3. These are the inflection points again, and the minus square root of 3, 0, and square root of 3, okay, so plus, negative, plus, minus, and the concave down, concave up, concave down, concave up, and these are all inflection points, okay, and when you sketch this function, okay, approximately you will obtain this. This is +1, this is -1, okay, and the minus square root of 3, and this is square root of 3. These points are inflection points, and also this 0, okay, and as you see, okay, here is when you what can we say, here is concave down, okay, and I'm sorry for this part maybe, and the concave up, and again concave down, and again oops, this part is again must be cleared, and this is concave down and again concave up, okay, and inflection points like that, and the local maxima and local minima points can be seen, okay, and this is the graph of our function, which was, it was the y equals to x times e to the minus x squared over 2. Okay, and the sketching graphics, okay, important, and you can find lots of problems end of your subchapter, which is the 4.4 subchapter. Okay, now I want to continue with the 4.5, the extreme value problems, okay, and the okay, and the example, find the absolute maximum and minimum values of y equals to x to the power of 2 over 3 on the interval, okay, minus 2 is less than x is less than plus 3, okay, and the solution, and the firstly y prime equals to 2 over 3 x to the power of minus 1 over 3, and we know that y prime is not defined at x equals to 0, so no critical points, okay, but the x equals to 0 and the y equals to 0, these are the singular points, okay, and the endpoints f of minus 2 is equal to 4 to the power of 1 over 3, and the f of plus 3 and it will be 9 to the power of 1 over 3. So these are the endpoints. Okay, and we know that for this function, these are the endpoints, -2 and +3, and here is singular point, and we can say this point has the cusp, okay, and this point is local maximum, and this point is, okay, absolute maximum, and we know that this point is absolute minimum. Okay, now we remember this graph again, and let me continue with the example again, and this example is about the extreme value. Okay, if the corner point of the rectangle is movable on the circle, then find what the largest area of rectangle is. Okay, and I mean that this is our circle, and we have the movable corner of the rectangle. Okay, and what can we say about this corner? Okay, for example, this point is x, so this point must be -x. If this point is x, what can we say about here? Okay, and it must be, we know that the, okay, and the rectangle is x squared plus y squared equals to 4. Okay, I'm sorry, this is the circle formulation, and what can we say about here? And the x comma square root of 4 minus x squared here is, and this point must be -x comma square root of, okay, 4 minus x squared, okay, right, and this part must be 2x, okay, and we know that the y equals to, okay, square root of 4 minus x squared, right, and the area of the rectangle must be 2x times, which is 2x, and the length, which is the square root of 4 minus x squared, and therefore, okay, x is larger than or equal to 0 and less than or equal to 2 values. Okay.